And now I'm delighted to welcome Nathalie Marcotte, SVP and President of Process Automation at Schneider Electric, who will be giving an enterprise story, which is called From Concept to Implementation, how rapid deployment of AI solutions can drive faster business impact. So over to you, Nathalie.
Thank you, and hello, everyone. It's a real pleasure to be here today, even virtually. And thank you for the time you're taking. Recently, in the industry, we all want to accelerate the potential impact and promises that data and digitization has on improving operations, improving sustainability, while we do ensure worker safety. So even more powerful are the discoveries you can capture from artificial intelligence. The smart data-driven approach that learns pattern to make informed predictions and automate certain processes. So for the next 15 minutes, I will be discussing challenges and approach that can be used to accelerate the use of artificial intelligence in the industrial and manufacturing environments, which bring its unique challenges. I will also discuss associated benefits. But before I do address this topic, and to provide a bit of context, let me share a little bit about who we are and what do we do at Schneider Electric. So at Schneider, our purpose is really simple. We want to empower all to make the most of our energy and resources. We fundamentally believe that technology allows us to bridge progress and sustainability for all. On one hand, you have to bring energy to all the people who don't have access to it in the world, and that's about 2 billion people on the earth. And at the same time, you've got to make sure that the carbon footprint of the energy and resources will be divided by 2 in the next 20 years. So that's quite a challenge. So in fulfilling this purpose, we see our mission in a very clear manner. We want to be the digital partner in sustainability and efficiency for our customers. We have customers in many industrial and manufacturing segments. Let me give you some few examples: oil and gas, mining and metals, really heavy industries, water and waste, pulp and paper, food and beverage, transportation. So many wide segments. All comment they have industrial and manufacturing space. The main challenge in front of all these segments, in front of all of us, is obviously climate change. And really together, we have to change the trajectory of carbon emissions and therefore climate change. At Schneider, we are committed to rethink what's possible in the industrial settings. And in order to really truly reach this next generation efficiency that will balance both sides, resiliency and sustainability in industries, we must make bold moves. So one of these bold moves will definitively be enabled by artificial intelligence. And we do believe AI is a major catalyst for scalable solutions for the industrial business. We're not the only ones who believe so. A recent survey from ARC, which is an analyst in our space, shows that 40% of respondents believe AI will impact the industry in some way. It is critical to leverage AI for industrial operations and manufacturing. So in order to do that, we first need to understand what it can do in this environment, what's possible. AI does bridge human expertise with learned data-driven behaviors, allowing to significantly transform the effectiveness of any resource, system, asset, or process. In the industrial space, we often get the question from our customers: how can I constantly improve efficiency while I do ensure uptime? AI can bring answer to this question with database model made to predict outcome, such as when will this asset fail, or when and where am I wasting energy, where am I operating at the optimal energy point. So there lies the challenge. How can we build the right models for AI? So to address these challenges and the perspective of most industrial companies, we must invest in experimentation, data models, and we need them to be as dynamic as the human intelligence they are meant to emulate. So we've invested in talent development, predictive analytics, condition management tools, for example, to enable customers to predict failure long before downtime actually happens. We've been using the power of AI to facilitate interactions for positive business outcome, and we empower our customers to really do the same. So in order to achieve so, we see three essential components that are shared in the industry, really to untap the impact of AI in our space. The first, obviously, we need to have data accessibility. In order to have data accessibility, we need data preparation. The second step is being able to rapidly deploy. There's so many applications of AI that we need to identify the one that will give you the best return on investment and identify them rapidly and deploy them rapidly. And once they're deployed, the final step is make sure that you operationalize these AI in a real time and that they stay constantly providing the business outcome that you're looking for. So let me share some scenarios which will exemplify these various components or steps in the process. So the first challenge has to do with data preparation in existing industrial fleets. For instance, in a process plan, there's a tremendous amount of data which is generated across the various stages, and it can be quite cumbersome. It's a big task to have each stage work seamlessly and being integrated together. In new plants, when we build new plant nowadays, there's a lot of new tools. We can access digital twin, which is often used to cover the full life cycle of the asset and the facilities. However, these nice tools that are available when you build a brand new plant today, they're not available for thousands of existing industrial plants, which often have their design documents, such as control diagram, all of the documentation in the form of handwritten, drawn out spec. As these existing industrial plants, they also want to attempt to become more efficient and sustainable by reducing carbon emission. They need to optimize their siloed processes with integrated workflow, obviously enabled by digitization. So how do we ensure proper data access? First, we need to automate the process. One of the approaches is to automate the digital recreation of these design plans. And we have some example where we use AI actually and machine learning to do that step in a more efficient way. Then you need to validate this data, because some of these plans, the drawings that you're using to automate and to recreate the data may not be completely up to date, so you have to validate. And only when these two steps are completed that you can deploy additional value-added solution using that data and then continue in real time. So to support this full transformation, it's critical for human input and data quality to be consistent across multiple vendors and operators. So this will ensure that system application can identify patterns and start learning behavior from shared legacy expertise. So let me give you an example with a customer of ours in the high hazard industry who wanted to set up an advanced alarm system for the operator, leveraging some insights from their process and various elements. The challenge they had is the information and logic required was spread over 30,000 control drawings that needed to be digitized and rationalized to enable this advanced alarming scheme. So these two sets of data needed to be correlated. So AI and machine learning was used first to capture the data and then to correlate them together and then make the association between the two automatically. So using this approach, they were able to save significant amount of time as well as removing risk of error, human interface. And now they start to build their data data preparation, they have a much richer data set that they can use to build other AI applications. So let's talk a little bit about the next step in some of the challenge we're also facing in the industry is how do we get out of what seems to be the never-ending proof of concept stage? In the industrial space, you can have so many applications of AI. The challenge is across the board, and we have to balance data availability, as already mentioned, but also requirement of customization and the return on this customization investment. So one way we've chosen to do this is by developing hands-on process with customer to consult, execute, integrate better designs into their automation system. It's a foolproof process we work on with our clients to help them achieve their strategic vision. We do test specific use case. The success criteria are predefined with the customer. We implement the right technology. And then by using artificial intelligence in a predefined field trial, we are enabled to scale up or fail fast. So it's really accelerate the process of learning to decide, does it make sense to continue? Or, do we move on to maybe other potential application? So we've seen similar approach applied to other domains. So what we did, though, is to adapt this to the OT environment to achieve the rapid validation that we needed to so we get out of this proof of concept phase that we're in all the time. So let me also give you a real life clear example. With one of our oil and gas production company in Southeast Asia, we analyzed the trends of abnormal process events detected by machine learning models. We've closed the loop to effectively override pump settings of the automation controller. So what happened is with this approach, we have reduced the stress on the system, on the asset, and hence extended the lifetime of the pumping equipment. Additionally, what we've seen is production increase by more than 10%. And at the same time, we've reduced energy consumption by this pump, by operating in a much better condition by over 30%. So following this phase where we've really tested the validate the process, now we've extended this use elsewhere and we're able to operationalize AI to really drive continuous business outcome. So let's take another application in the industry where AI was applied to maintenance this time. So industrial plants generate and track install system which comprise of group of assets that comes from many multiple vendors. For these assets, there's many health indicators that are transmitted by means of digital log files or other monitoring mechanism. This data is continuously generating and quickly becomes significant in terms of size. You also have to put yourself in the context of an industrial environment where the life of an automated system is usually average 20 years. So 20 years of online continuous data could, you get massive amount of data that you have to treat. So due to the magnitude and complexity involved, it is honestly almost impossible to analyze this data manually to look for anomalies without expending a lot of time and effort. And that, while you're doing this, it could lead to plant outage. So it's really essential to bring the data from large, disparate, and isolated health indicators together for cohesive system view, while also digitizing human experience, insight, and expertise. So these two inputs, human and machines, allow for future continuous operation. It will also support maintenance team by summarizing complex data into clear diagnostic, identifying root cause analysis, informing them of simple corrective actions and predictive future anomalies. As another example, we've used this approach with a global energy operator customer in the Middle East who generate a significant amount of data in their plants. So we work really together with them we've implemented the AI technology, which analyzes historical data, and we were able to identify patterns of potential failure. Because of the potential fault being identified in advance, the customer are now able to take proactive actions before really impacting operations, which does increase uptime and obviously save a lot of save a lot of energy and production. So that said, restructuring Flight Health Indicator into this framework, doesn't come without some potential challenge that we also had to overcome. Fear of false positive was one of them. So failure to understand complex system, equipment, and relationship for modeling or an efficiency, capturing human expertise throughout the entire value chain. So both with the persistence, collaboration, and training from human and machine, the system now continuously learn and speed up accurate decision making and reducing the risk. More it learns and as it stays up, reducing the risk of having these false positive or taking the wrong action based on the wrong information. As a result, production outages are avoided, and you can imagine, as I said, saving millions of dollars in potential loss of revenue, and the maintenance team can effectively plan and prepare their scope of work. So although AI is complex and requires data scientists, there's such potential for companies' operational performance if this technology is used that really we have to find a proper approach to make it happen. So we've recognized the uncapped potential and we've invested in predictive analysis at Schneider Electric and in the industry, tools around condition management, as well as team of people that can address them. By using the power of AI to facilitate interactions, our customer can ensure positive business outcome at scale. So with first, standardized data preparation, that's key. Implementation of rapid validation and deployment to make sure that they get the value as quick as possible. And then moving into an operationalized phase where AI provides business impact on an ongoing basis. So if you're curious about new ways to innovate your industrial operations, I encourage you to learn more about an approach, this rapid validation process. It's collaborative, co-innovative approach to improve value and scale up efficiencies at different facilities. So feel free to contact us directly if you want to know more. And I want to thank you for your time. Certainly excited to talk, some more about that topic with some of you in the future. Thank you.
Thank you so much, Nathalie.